Okay, I was not in the root. Typo. Yeah, well, this is starting. Yeah, let it start. Yeah, I believe it is started. So let's set this up. So I can run this setup. It gives us okay. Remember, you have to open your outbound firewalls for this to work. Right. So official MuleSoft documentation has all the URLs, ports, and whatever the things that you need to whitelist for the information to pass out of your system to MuleSoft. Right. Yeah. So now this is done. Let me see if there are. It takes around 5 minutes or more than that to reflect. But yeah, so now we have successfully installed the monitoring tool or the monitoring agent. Now, if you deploy an application on the server and you know after a couple of time, if you observe, okay, let me try to see if I can deploy. I have an greetings API. I'll deploy to my Mule one where I've installed the anypoint monitoring. Yep, it has started. Yeah, there you go. Now you can see similar to the Cloud Hub, dashboard. So I mean, if I had not installed the anypoint monitoring, it would be something like this. Yeah, right. So you get a lot of metrics as I have just uh, deployed the application. I don't say anything, but after your application starts working on the request, you'll actually see the information. Yep. So that's all with the anypoint monitoring. If there are no questions on this, I'll move forward to the next slide. Okay, I'll take that as a no. Yeah, the good part, CPU affinity. So what's CPU affinity? So you know, CPU affinity actually tells your process, whatever the process you mention, it will run on specific cores of your processor, right? So your processor might have multiple cores. Like for example, my Windows system has around 8 cores. So you cannot run your application on all 8 cores unless you have the license, right? So when you buy the on-premise license, the license will come with the restriction or the specification of how many cores that you can run your runtime on, right? So now if you have only if you are only allowed to run on 2 cores and you deploy it in this particular system, it has 8 cores. So the system will allocate to whatever the core it feels appropriate, right? So you cannot run on 8 cores. Then you are not in compliant with the license that you have acquired, right? So then what's the work around, or what's the way that you can ensure that your application or your runtime engine runs on only particular set of cores that you mentioned. So that's called CPU affinity, and we can actually do it. So these are the consideration before the these are the consideration that you have to take into account before you configure CPU affinity, because the CPU the allocation of CPU depends on a lot of things, and also there will be cache that will be shared between the cores that you need to take into consideration. So all these things you should consider before making any changes, right? So there are couple of ways that you can do that. I'll start with a simple one. For example, if you're running in Windows, you can actually open the task manager, and you can go to the details, and let's say I want, no, here I'm selecting Chrome, but uh, if you want to do it for Mule runtime, you'll have to do it for two processes. One is the wrapper, Java wrapper, and the actual Java service, right? So those both of those processes are belong to Mule runtime. So I can give a right click, and I can see set affinity. So when I open this, it shows now eight cores are selected. So it runs on all cores, whichever is available, or whichever is appropriate. So now I can uncheck, and I can say run only on CPU 0 and CPU 1. So this is how you set it. Uh, in Windows, it's actually easy. Uh, then how to set it in Linux? So there is a command called task set that you can use to do that. Task set is a bit complicated because you need to understand the bit mask, right? Bit mapping or bit mask. Now it's not straightforward that you will go ahead and say 0 and 1 like you do it in Windows. You'll actually have to give it the mapping. So it's a bit, you can go wrong. MuleSoft, one of the MuleSoft articles have provided a utility which we can use to set this. So they do not officially support this, but you can use it to set and monitor the affinity or CPU affinity. So now if I see here, I have downloaded these two from the official MuleSoft article. Uh, but using this will be at your own risk and your own discretion, because MuleSoft doesn't officially support it. It internally uses the same thing, the task set, but it makes simplified for us. When you run this, you just have to give what course that you want this process to run on, like 0, 1, 2, 3, 3, 4, 6, 7, whatever you would like this runtime to run on. So now, what are the things that you need? You just need the process ID, and you just need the course, right? The ID of the course that you want to run this on. So now, where do you get the process ID? In your home folder, you can see there's a file called mule_ee.pid. So if you check the contents of that file, this is your process ID. So now I can, so this affinity monitor.sh file will take the uh, process ID as input and give me the what are the cores it is assigned to. And if I want to set affinity, I can use the affinity set.sh. So let's first see what cores this process is using. So I'll say 744. I'll- Oops, I'm in Mu. You can see. So, okay, I'll stop here. You can see the process tree. As I said, there will be two process, wrapper and the Java. So 744 is the parent, and these are all its childs. Everything will be running on 0 and 1. I mean, everything is running on. You can see these are all the numbers of which are showed here. This is the process tree. So you can see and here you can see it, everything is running on 0 and 1. So now I don't want this to run on 0 and 1. I want to run this on maybe, 1 and 2. Let's do that. Let's see how we can do that, right? So affinity set.sh will take two parameters as input. One is the process ID, that is 744, and the course that you want it to run on, right? So I'll say 1 comma 2. I think I only have two cores. Yeah. Okay, no problem. But I think you got the idea. So now I have set it. Let's see what it is. Yeah. So it ignored the second one because I don't have the extra core. But you can see now it is running on only one core. So let me quickly revert this. So that's how you stay compliant. Ah, yeah, it's back to 0 and 1. Right. So any questions on CPU affinity? All right. I'll take that as a no. Moving to the next part, server groups, right? So,
Sunil,
mm,
one question.
yes, ma'am.
So, showed that using the the script file, we can set up the CPU and everything, right?
Mm,
Now, as I know, every time you restart, the process ID of the wrapper service changes.
right.
Any workaround how we can, ensure that, suppose, say, today I am a administrator, I am restarting the server, but I don't know that there is a script that needs to be run to set up CPU and affinity. It could be human
Mm,
miss, right?
mm,
Any
mm.
way we can automate that?
That's a great question, Suman. Yes, you have something in Windows, startup processes or startup things that you want to run, right? Similarly, you will have something in Linux. Right now, it's not on top of my head, but yeah, you can create a shell script that will kick off the Mule runtime, and once it is up, it will take the that's the way you have to develop it. You should take the process ID from that file once it is up, and then set the affinity, or you can do that manually every time you restart. But yeah, that's how you automate it. You can similarly run a bat
Yeah, let
file.
let me answer that to Suman. So whenever we're running, Suman, you remember like for EMS server for TIPCO, we are doing the same thing. The PID, whenever you are restarting, the PID will be auto-generated, right? So we are writing that script and keeping into the some metadata from where it will be synced. So similarly here for either of the server, whether Windows or Linux or Rails server or Macintosh, doesn't matter. You have to keep that particular file, that script, into your main OPT mule server, not into the bin file, because that will be taking that AM file from that particular location. So whenever that will be kicked off, it will take that. If anything already shared into the particular PID's location, if there, it will take that. If not, it will be regenerating. Does that answer your
So
question,
when,
Suman?
Yes. Sorry, I was unable to unmute, so I wasn't able to answer
Yeah,
that.
no worries.
yeah, yeah. Moving on to the next topic, server groups, right? So what's a server group? So server group is nothing but a couple of more than one server working together. I mean, not what I mean is they will act as a single deployment target. What I mean is um, you can create a group of you can have multiple servers and group them, and you can deploy applications at once to all the servers. And this provides redundancy. Let's say in this server group you have four nodes. You call servers in a server group or a cluster as node. So let's say an application running on this node is sorry, this there is an application running on all these servers, and one of the server went down. Then the other server, will you can start up the other server, and you can have it working with very less downtime. So you have redundant servers at your hand whenever you would like to use them. So that's the main advantage of server groups, and there are a bit of restrictions to it. Your runtime version, your agent, and the Java version should be same on all the server groups for you to deploy an application, right? So let's say you have 4 servers from your runtime manager. You can add all these servers to a group. I'll show you. So now here I have. So I can create, add a server, new server, I can create a group, I can create a cluster, right? So when I click on create group, I can give this any name. I'll say my server group, and it will show me what are the available servers, if right, that you can add to this group. Uh, right now, I think Mule one is different. Yeah, because I have installed the agent right there. So it will show all the compatible servers that you can add to the group. You can select those and just click on create group. That's it. It will create a group for you, and that will be shown as a deployment target in your runtime manager. So when I click on deploy application under hybrid, you will see the group name. In fact, I don't need a server to create a group. You can create a group and add servers later to it. So now here is the group. I can add whenever I want to. Let's see. This is. I don't think it is available because there are no actual servers to it. Yeah, it's not available. But yeah, that's how you group your servers. There, as I said, there are some requirements and restrictions to it. Like the version should be same, and the servers with running or disconnected state are allowed to group together. What I mean by that is, let's say you have 4 servers. When you create a server, or when you register your server with the runtime manager, or the runtime agent, it will be first in the created state. Only after you restart it, it will move to the running state, right? And if there are any issues after running after the running state, it will go to the disconnected state. I mean, if your server is down, right? So now, if any of your servers are either in running state or in disconnected state, you can group them together. But in the same group, you cannot add a server in from which is in the created state. Yeah, but you can group as you can group the servers which are all in created state, right? So let me say that again. You can group the servers which are in running and disconnected state, but you cannot add servers to that group whose status is created, right? Now you can group created servers separately. And before you and the other thing is, let's say I have a server that I want to add to the group, and that has an application, or maybe 2 or 3 applications, whatever it is, so running on that server already. Then if I want to add that server to this group, I'll have to delete all the applications on that server before I could add here. Yeah, that's the disadvantages. Yeah. So I'll move.
Alongside this point, here is a catch. You can create a script for the self-healing for any server group. Let's say whatever Sunil told, like you need to restart, and if it's a running state, then only you can whatever the stuff you can do for the operation things, right? So for that is nothing but the self-healing. So for the self-healing testimonial, whether this is an active state or running state, or whether this is an application is already there or not, if you want to add, so that easily you can create a self-healing script, and you can automate that script like every whenever there is an application going to be deployed, you can run that script, or you can schedule that script every 15 minutes or 30 minutes, and you can give a report to the DevOps team or the operation team. So that is an additional catch point. Whenever you are promoting the server groups to your customer, you can automate that script actually.
Yeah, thanks, Broj, for adding that point. That's a great point.
Yeah, sure.
Yeah, moving on to the next one, clusters. We all love clusters, right? So, what is a cluster? Cluster is nothing but a group of servers acting as a system, as a single system, right? Now, in the server groups, none of the servers are aware of the other servers in the group. They all act independently. Everyone will be listening to your event sources, or process all the messages that they get, right? So now you can run into concurrency issues, like for example, uh, you are having a file listener and someone has put a file over there, and you have the application running all of the servers. It will all the applications, not necessarily, but there is a chance that the multiple servers will pick the same file and process it. Sorry, someone trying to speak. Okay. So yeah, you can run into concurrency issues, not only with file, or for the other connectors as well, like the MQs and the other similar stuff, right? So here in clusters, every server or the node is aware of the other nodes in the cluster. So that way, they will all communicate with each other, and they will process the message. Even if there is a failure, the other server try to pick and process from where it has failed. And the how do you achieve that? That is with the distributed shared memory, right? So every node will have the memory, and it will share a part of its memory, as part of distributed shared memory. It's a other different concept altogether. So basically, every transaction details, or the metadata, or the necessary information is available in the distributed shared memory, and it is accessible by every server, and every server has a copy of it. And in the event of failure, or even in the event of fault, the other server or other node from the cluster will pick it up and process from there. So it provides you great fault tolerance. So you can achieve high availability. Likewise, as I said, if this is down, the other can pick. You have high availability. Your system is available all the time. And you can achieve fault tolerance, as I said. If some message gets uh, you know uh, failed, for whatever the reason in between, like the server crashed or something, the other server can pick from the same place. But you'll have to design in such a way. It's not by default. It's not that you create a cluster and expect it to work that way. You'll have to design and architect your applications in the server in such a way that in the event of failure, the other server can pick it up. We'll come to that. And you can scale it seamlessly. It's just that you can add a new server to the cluster, and voila, you have one more server serving your request. And as I said, it solves concurrency. How does it do that? In the event sources, right? For the most of the event sources, like your database listener on table row, those listeners, there is a parameter called run on primary node only, right? On primary node only. So when you check that, it the for example, yeah, I forgot to tell you that. So every cluster will have a primary and secondary and other stuff. So what does a primary mean? So in the event of the primary goes down, the other node will become primary. But the main intention is that the event listeners, right? They will listen only on the primary node, and the others will pick it up, right? So I mean, the design should be in that way. So you can select the run on primary only, or on primary node, and deploy it to your cluster, and it will only the primary will listen to the events on your connector. Like say you have a database and you insert a new row, only the primary will pick the row, and then you design your system to load balance this, either if this server is busy, it will just pick it up and send it to a async queue, and the other server which is available will pick that from there, right? So you have two types of clustering, unicast and multicast. In the unicast, you will have to specifically tell what are the other nodes in the cluster to each node, right? So let's say I have this node and this is primary. I have to configure this, the IPs of other nodes in the cluster. So now two things to consider. You cannot have DHCP, because if you assign dynamic IPs, then in the event of restarts or expiration of that IP, or whatever the reason, your IP gets changed, you will have to again reconfigure it, right? So try avoiding having DHCPs. And also there is a recommended limit of how many number of servers that you can add to a cluster. It's 8 from MuleSoft. So 8 is the recommended level. You can add more than that, but MuleSoft does not guarantee the performance or stability, right? So what are the things you need? You in the unicast mode, you need IPs of all the servers in your cluster, and you need to open the 5701, 02, and 03 ports open in the TCP, and you will have to make sure that there is two-way communication enabled between all the servers, right? One to many, all the servers, you'll need to have communication between them, because they will continuously communicate with each other, saying that, hey, I'm here, I'm alive, right? So if you don't have this, there is a risk that all your servers or all your nodes in the cluster will think that there is no other node in the cluster and I am the primary, and it will pick the message and it will process duplicates, right? So you need to avoid that. And in the multicast mode, uh, you don't have to specify the IPs of the servers. It will automatically get the information from the multicast IP address. So you need to again keep the same ports open for multicast as well, and you need to make sure that two-way communication is enabled. And apart from these two, you will have to open the 54327 UDP port open, and you have most of the networks will disable this. You'll have to have your network engineer to enable the multicast IP address, because this is the IP and port on which every server sends information and the other servers listen. So that's how you do not have to actually configure the IPs of other nodes in your cluster. So that way, even if you have DHCP, it's good. So yeah, that's how multicast works. It's the only difference. You don't have to worry about the IP addressing, but you'll need to take care of the enabling of multicast IPs and UDP port and the other ports, right? So how do you create a cluster? Same way, you create a group. I will delete this group for now. So I can click on create cluster. I'll say my cluster. Okay, I'll just add one. I don't think it will let me. So you need at least two nodes. As I've added the anypoint monitoring, I was not able to do this. Let me see if I can install the anypoint monitoring here as well. Just give me a second. Meanwhile, if you have any questions, please let me know. I'll just reshare after I do this. Please let us know if you have any questions.
Also, you can highlight Sunil for the people what is the beneficial for the real-time application, then rather than event-driven batch or NQ publisher, which could be the better option like server group or cluster. How we can select, like if a customer has a biasness or they have a need for a real-time, like out of 100 application, 90% application are real-time, but on the other hand another customer who have that event driven and batch processing or MQ based application rather than the real time, what could be their good option or opt-in option for server group or cluster? That point also you can highlight.
Yeah, yeah. So when the major advantage, right? So is the load balancing in clusters. So if you have, let's say you are expecting a lot of load and you want to, dynamically let the servers handle the load, you can design your cluster in such a way that you can have the basically you'll have to the whole implementation you'll have to break it into parts, and between each part, right, you generally do it in everyday life in Mule API development. You'll break down your requirement or the design into subflows. And a good practice is that you can put the async the queues or database, or whatever the supported clustering available connector, or the component. And then you will have the data passing through the VMQ. You can use the VMQ object store, database, JMS, any other thing. Let's take an example of the external MQ service. So at each subflow, I'll send the data to after each subflow. I'll send the data to a VMQ, or the MQ, and in the next subflow, I will listen from there. Instead of a flow reference, you will have a queue over there. And in the event of a crash, or in the event of in the event of heavy load, all the other nodes in the cluster, right, can pick it up and process. And Let me take a good example out of top of my head. um, mm, this first. Yeah. So similarly, the VM queues, right? The VM queues provided by MuleSoft, and the uh, object store supports this distributed shared memory. So uh, it in a way load balances the load, or the traffic. So now when you instead of a flow reference, if you put a VM queue and put a listener for the VM queue in the next flow, so it is not necessary that a particular application on a particular server should pick it up, as it is in the distributed shared memory. Any server which is available can pick that and process it. And for batch processing, there is a catch. I don't want to go to more details into it, but that in the batch processing, a server will batch that, and create a queue, and do a lot of stuff in the behind the scenes, right? So what if when you aggregate it, and after aggregating it failed, right? So now this information is not available on other nodes in the same cluster. So other nodes cannot pick it up and process it. So for that, you'll have to use other third-party solutions, which I will not go into. And if you want to have high fault tolerance, you can use transactions. In the event of failures, you can roll back, and other servers can pick it up and process.
Any question? Any queries, guys?
Sorry, it's taking a bit of time. Just bear with me for 5 more minutes. Meanwhile, you can put your questions in the chat. And with the sorry, with the transactions, right? If you have the transactions enabled, you will be hit with performance issues because transactions are pretty heavy, and if you have transactions for every mule message or event, it will be heavy on the server, but you'll have to take a conscious decision. So if you're a customer or you need to achieve high availability or fault tolerance, what are the what are the things that you can ignore, what are the things that you can, what are the takeaways, right? So you'll have to uh, sacrifice some things to get the others. Totally depends on your requirement. Again, I'm sorry for the delay. I should have set this up, but I wanted to show you. Almost there. I don't know what the issue is, but I'm unable to get that. Might have done something wrong. But yeah. So basically, you go to cluster. When you select unicast, I hope my screen is visible.
Yeah, yeah, we can.
Yeah. So basically, you go to the runtime manager, and under the servers, you select the create cluster, and you can give your cluster a name. You can select unicast or multicast. As I said, only difference is that the other nodes in the cluster doesn't know. Sorry, you'll have to specify it manually. Yeah. So it will automatically show you the IP address and the port, right? As I said, 5701, 02, and 03 are the default ports. If you provide a custom port, you will have to enable the firewall between those two servers to in order for it to communicate with each other, right? So I'll let it be default. You can say cluster, demo cluster. Okay, there's a server. It's server. So in your home page, you'll have a folder called as .mule. So you can see it. So if you go to the folder, so there are two ways actually. So they you can create a cluster from the runtime manager user interface, as well as you can do it from the server. So how do you do it? You come to the folder, you add this file, you create this file, like just cat this. So there are a couple of parameters that you can provide to this file. That's all detailedly mentioned in the official documentation. But these are the minimum required items, and I'll go through each of them. Yeah, Mule cluster nodes, right? So this is where you add the IP addresses of all nodes in your cluster, right? So let's say if I have other three servers, I'll have to add the other IPs by comma separated here, so that it will communicate with it. And cluster size you can see as 0. If when you create a cluster from the runtime manager, you will see it as 0, even though if you have 3 4 or more than 0 servers on the cluster. But you don't have to worry about it. This is a known thing, and MuleSoft official documentation states that you don't have to worry about it. And the cluster schema, I'll not talk about it much because I don't have much knowledge on this one. But you have the cluster ID. That's the ID of your cluster. Every node in the cluster should have the same ID. And you have the multicast enabled as a boolean value. So if it is false, then it means this is in the unicast mode. If it is true, then it means the um multicast mode. So in the multicast mode, you don't have to specify the IPs. And this is the cluster node ID. So this is the primary. So the for the others you can see as 2 3 4, and likewise. So that's how you do it. If you do it from the runtime manager, it will automatically create the file. If you want to do it manually, you can create the file and restart the servers, and then it will all run in cluster mode. So this is what I wanted to show you. Um, let's go back to the presentation. See the last slide for today, the high availability options. So uh, to achieve high availability, right? You can have multiple ways that you can design your servers, in case of a failure, right? You will have a redundant server readily available to recover and process the request. And one more thing I wanted to tell you, in the multicast clustering, it's always recommended to have the servers. Oops, we are not there yet. So all the it is recommended to have all the servers in your cluster in the same network, or in the same subnet, because you can still have servers in other geolocations for fault tolerance, or sorry, for high availability, because in the event of failure, or a crash in a data center, you will have other server from the other location available. But for that, you will need to have a VPN tunnel setup, and the internet between these servers should be very fast if you don't want to run into performance issues. So it's recommended in multicast mode that all your servers should be in the same subnet or the same network. Yeah. So that's the point I wanted to tell you. And you can also have servers from different data centers. I'll go through that. I mean, after once we finish the HA options. So we have cold standby mode, in which you can have multiple servers, or let's say, let's take this pictorial representation. So you see here two servers, and um, one server is on and the other server is completely down. The operating system, it's actually turned off, right? So powered off. So one server will be on and the other will be ready, um, for you to on it. So in the event of this server goes down, you will have to turn power on this server, and then start the runtime engine. So it will take a bit of time for you to recover from the crash. And you have warm standby. In here you will have the one server having running active, and the other server will be powered on, but the Mule runtime engine on the server will be down. So in the event of crash on this server, you'll just go and start the runtime engine. So it's pretty fast here. And coming to here, hot standby, active passive. So here you will have both servers up and running, and both runtime engines up and running. But you will only send the traffic to one server. Only when this server is down, you will send the traffic to the other available server. And the last mode is hot standby, active active, right? So in the active active mode, you will have both the servers running same applications and serving request to the serving the request, but you will have a load balancer on top of it. So that load balancer will determine uh, each request, to which server it should go to. So you can have a load balancer here as well, if you want to use this server as well. So in the event of this failed, this will pick it up. In the event of this failed, this will pick it up. And even in the event of this whole data center goes down, or the cluster goes down, the other cluster will take it up, right? Yeah. So this is nothing but a section of this, right? So now the last point I wanted to tell you is that in clustering, you have, as I said, you can have servers from different data centers in the cluster, but the catch is that there could be a possibility of processing duplicates because of the latency or the network issues. As I said, if there is a network issue, every node in the cluster will think that it's the only thing in the cluster, and it will start processing, acting as primary. So how do you kind of control it in a way? So there is something called as quorum management, uh, which you can enable on the pod level as well as on the application level. So what quorum management says is that you will have to declare the size of the quorum. Let's say I have two data centers, and each data center has one data center has three servers and the other has two servers. So I can say that for my cluster to perform as it is, I can say that the quorum size should be three. So in the case of the data center that crashes with the three servers, and the other two servers data center is functioning, it will not. I mean, it will take the request, but it will eventually fail when it hits the distributed object store or VM queue. So the calls to your object store will fail. So it's that's why it's highly recommended to have your clusters running in the same network. Yeah, that's all I have for today. If you have any questions, please let me know. So this is a very vast topic, the clustering and high availability and fault tolerance. The official documentation covers most part of it. You can visit the documentation and learn from there a lot. Any questions?
Yeah, there are a question like if cluster is down for some malware attack or cyber attack, how we can achieve that. But it's all behind your PPC and VPN, so that chances is very minimal because your network team is there to take everything. We are not exposing our servers to external parties. Only the API, URL, or endpoints will be exposed, not the server. Right? Any other question, guys? Yeah, I think no. Yeah, thanks Sunil, for the in detail depth for each and every individual topic from the management perspective, configuration perspective, installation perspective, and also the operation perspective. How you can manage the different method of the deployment, the worm, active, HA, FT, everything we have covered. It's a very informative.
Yep. Thank you, Braj. Thank you, everyone who have taken the time to attend this session. I greatly appreciate it.
Yep. Thank you all. Thanks once again for joining.
Yeah, thank you so much, everyone. And thank you, Sunil.